It's 2 o'clock. We still have some people coming. I will check waiting room from time to time, just to make sure that everyone is here. Hello, everyone. Thank you very much for joining. And yeah, just a quick note, this recording, this webinar is recorded, so and it will be uploaded later on to IAF YouTube channel, so you can check it out as well. My name is Anna Stroginis, and I'm a part of ECR group, Early Career Researchers Group, and we are actually supported by International Institute of Forecasters, which is really great for them to support us. And today we are going to have another webinar that will be led by Paul Goodwin here. And a couple of notes that I want to introduce our team first. You do see my slides, right?
Yes.
But I can't somehow. Can I? Okay, that's strange. Yeah, this is our team. We have Sherry, Michael. I guess some of them are here. Margaret and Sarah, who are here as well. And our team is actually created to support early researchers into entering this community of IAF. And the main idea is to organize different events, different webinars. We do some events during ISF. Some of them, they were offline last year, not last year, 2019. And this year we did some interactions again, and it was great to have you here. And so we, as I said, we arrange different events, and webinars is one of our activities that we also try to do from time to time. And we aim to do these webinars every 2 or 3 months, so quarterly, more or less. And to check more about our events and different activities that we run, please do subscribe to our either Twitter, LinkedIn page or Facebook, whatever you use. And also, again, you can find our videos on IAF YouTube channel, and there is a link there. So yeah, tip of the day, take a quick screenshot or see this later on. Again, I do sometimes go to the waiting room and add some people here, so sorry for that. Okay, and what else? I want to say some basic things about this webinar. You're all muted initially. If you want to unmute, you're welcome to ask questions afterwards. That is great. Also, do use video. We like to see our audience, but it's up to you. And yeah, we always love to see our audience. And also, again, this webinar is recorded, and later on it will be uploaded to IAF YouTube channel. So you're all aware of this as well. And again, in Zoom, you can actually change your name and do some anonymous stuff if you want. So it's up to you. And the last thing that I want to say, that today we have Paul Goodwin, who is an excellent researcher, who is actually Professor Emeritus at University of Bath in the UK. And I'm really looking forward to this talk. And first of all, Paul is an amazing writer as well. So if you know, he wrote some books like For Wanted, A Skeptic Guide to Prediction. Too long for me to remember, sorry for that. That's why I'm looking at my notes. And the latest book was Something Doesn't Add Up, which is really also interesting in terms of statistics in real life and how it actually influence our perception from time to time. So, and today, Paul will be talking about lessons from career in forecasting research. Thank you very much, Paul, again for agreeing to present here. And let me finish my slides and give you rights to share. It won't take a minute. Paul, check if you can share your screen. Again, we have 31 person here. Thank you very much for joining us. Okay. Paul, floor is yours.
Okay, I'm just trying to get to the, give me a second.
Yeah, no problem. Recording is on, so.
Right, sorry. So can you see my slides now?
Yes, it's not in presentation mode though.
It's okay, yeah. Right, we're slides, so give me a second. Okay, we're in business, I think, hopefully.
Yep, great.
Okay, well, thank you for that introduction, Anna, and thank you for inviting me to give this talk, which, as you say, is called Lessons from a Career in Forecasting Research. Can I first of all deny that the person on the left who's shouting at the laptop was me last time when we tried to give the talk using Microsoft Teams. Apologies for that, by the way, but I was literally shouting at the screen saying, I'm here, rather like on one of these nightmares, and I couldn't make myself seen. There was clearly something wrong there. That just could be the way I feel, however, when I get a desk rejection from an editor. So there may be some honesty to the mood displayed by that person there. So what am I going to talk about? Well, I'm going to give you, first of all, my perspective, the sort of research I've done, what my research interests have been, and the sort of research I've conducted, so you know which particular aspect of forecasting this talk is coming from. I'm going to spend a little bit of time reflecting on why we research forecasting, and why I think it's a noble topic to research. I always think that early career researchers can lack confidence, so I'm going to talk a little bit about developing your confidence as a researcher. I hope you don't lack confidence, but if you do, a little bit of advice there. Then I'm going to talk about some mistakes that I think we can avoid in forecasting research based on the long experience of researching forecasting. I'm going to look at what I think the attributes of a good paper are, very briefly. I'm going to look at choosing a journal, what sort of journals are the best ones to submit your work to. I'm going to talk a little bit about getting cited. And finally, I'm going to talk about potentially fruitful areas of research in forecasting. Looks like a long list, but I'm going to deal with some of those topics quite briefly. So a little bit about me and my background. Well, my main research areas have really been the role of judgment in demand forecasting, how people use their judgment to make forecasts of sales, how they use their judgment to estimate probabilities, for example. And I've particularly focused on judgmental adjustments of statistical forecasts, why people make changes to forecasts that come from the computer, and are they successful in improving the forecasts? I've done a bit of work in scenario planning and a bit of research in decision analysis, a little bit of theoretical work as well, but those are my main research areas, more the role of judgment than the role of statistics, although of course the two have a very close relationship. And also, just to show you some positions I've held, I've been an associate editor, then an editor of the International Journal of Forecasting, an editorial board member of the Journal Behavioral Decision Making, Futures and Foresight Science, Foresight, and I've been a director of the International Institute of Forecasting. I tell you those simply to indicate that I've been in many ways on both sides of the publication activities, both as an author submitting papers and as an editor judging whether they should be published. So that's why I've indicated some of the positions that I've held. So that's where I'm coming from. What sort of research have I used? Well, a lot of the research in judgmental forecasting involves laboratory studies where you give people carefully controlled sets of perhaps time series data, and you test their ability to make accurate forecasts using their judgment under a range of different conditions. Now, these studies often involve students, though there's some evidence that students are good proxies for real life forecasters in many situations, but they do involve students. And of course, in a lab study, it's difficult to replicate the forecasting environment where many real life forecasts are made. For example, reproducing the incentives, the motivations, the dynamics, and the social pressures of a real life forecasting situation. Difficult to replicate that in the lab. So I've also been involved with field studies where you look at real forecasts and real forecasters and look at how they go about their business. So I've sat in on forecast review meetings where managers sit around a table and look at what the statistical forecast is saying and decide whether to accept it or whether to adjust it. And I've interviewed forecasters. I've conducted forecasting surveys of forecasters, again, to look at why they do what they do and how they do it. Of course, field studies aren't perfect. Often you find the data sets you get from companies are incomplete or contain errors. They're often very short series. Some companies don't keep their data for more than a few months or few years. And of course, you've no control over the treatments. It's very risky doing an experiment in forecasting with a company, because if the forecasts go wrong, it will cost them money. So you've really no control over the treatments. So those are the two main types of research methods I've used, and they're largely complementary, of course, where one is strong, the other is weak, and vice versa. So that's my background then. I think it's worth spending a little bit of time, since we're all forecasting researchers, and asking, why do we research forecasting? Why not research something else? And well, I think we do it to find ways of making more accurate forecasts. That's probably obvious, and better calibrated assessments of uncertainty. Why is that important? Well, forecasts can save lives. They can avoid wasted resources. In an environmentally challenged planet, it's important not to waste the Earth's resources. Forecasting can help us to avoid those wastes. It can reduce costs. It can improve the quality of life. It can warn us of future threats that we face. We can project populations in the future, or we can project what CO2 levels will be 20 years from now, and they can warn us of things that we need to do to prevent those things happening. For example, I read somewhere that flood forecasts in Europe bring benefits of about 400 euros for every €1 that's spent. Such are the benefits of forecasting where floods will occur and what their severity will be. And of course, anybody who goes to a supermarket and finds their favorite products on the shelves, they can thank a forecaster for getting the forecast right, for getting the supply right to that supermarket. We also, I think, aim, many of us, to improve forecasting practice in organizations. Many organizations are excellent in forecasting, but many are not. For example, there's an excessive use of judgment where statistical methods would be far better and far more accurate. There's often a blurring of targets with plans and decisions. And there are also islands of analysis in companies where different departments keep all their information to themselves and make separate forecasts. They don't share information which will be useful to other people in other parts of the organization. It's been called islands of analysis. For example, I once went to a forecasting meeting where there was a lady who made forecasts for the British supermarket Asda, that they used to be part of Walmart. And she spent all day forecasting what the demand would be for different products. And when she got home, tired after a day's work, she'd put her feet up and watch the television. And there'd be an advertisement for Asda advertising the fact that some of the products were being promoted. Nobody had told her. She was trying to forecast the demand. She found out from the television that the products were being promoted. There'd been no sharing of information. So I think one aspect we're interested in is trying to improve organizational forecasting practices. We shouldn't forget that forecasts are done to support decision makers. We don't forecast for its own sake. We forecast to support decision makers so they can make better decisions. Also, our research can help people to understand forecasts and their strengths and limitations. Do people understand what it means when we say there's a 70% chance of rain, for example? How can we help them to understand what the true meaning of that is? and how they can make decisions using that information. I've come across senior managers, for example, who go to their forecasters and say, well, I'm paying you enough money. Why aren't your forecasts 100% accurate all of the time? Clearly, the managers don't understand the strengths and limitations of forecasts. And through our research, we can look at ways of trying to improve people's understanding of what forecasts can do, what they can't, and what they aim to do. Maximizing publications, citations, and reputation are great, and we should all aim for these things. No good at publishing work when it's not cited or ignored. But of course, these should not come at the expense of the above objectives. Primarily, we're in the knowledge generating business. If we can develop our reputation and get publications and citations, nothing wrong with that. But we shouldn't do it at the expense, I think, of those objectives that I've just described. Now, I want to talk now about being confident as a researcher, particularly if you're a young researcher just starting out. I think there's a danger, if you're a new researcher, of suffering from what's called imposter syndrome. You may have come across the term. Imposter syndrome is a situation where, despite evidence of your accomplishments, people have doubts about their abilities. I remember once being in New York early in my career. I was about to give a talk, and in the audience, I spotted a Nobel laureate. And I thought, goodness me, what am I doing here, giving a talk to a Nobel Prize winner? For a few seconds, I considered, should I fake a heart attack and rush out? But I stuck it out, and the talk didn't go too badly. But many of us, particularly early in our careers, have these doubts that in some way we shouldn't be there. We've no rights to be there. We are imposters. We're fraudulent. It's a well-known syndrome. And it can be exacerbated by unpleasant and negative reviews from referees for the early papers that we submit, or even criticisms at conferences. I've been to conferences where some people seem to specialize in being nasty to the speakers and potentially affecting their self-confidence. One of my early papers I submitted to the journal Omega. And there were 3 referees, 2 of them quite supportive. But one of the referees, his or her review consisted of 4 handwritten words. The author is confused. That's all it said. The author is confused. There's nothing else to the review. And of course, I was totally shocked and hurt by this. Am I in the right business? Should I be researching forecasting if somebody says that? I've since kept that report, by the way, and I've never managed to match the handwriting to find out who it was that wrote that. And despite that awful, rather brief review, Omega later published the paper, by the way. So we all get these negative, unpleasant reviews, which can affect our confidence as young, early researchers. This happens to all sorts of people. When George Danzig invented linear programming, a major technique of mathematical programming, and he presented it for the first time at a conference in Wisconsin in 1948, a senior academic dismissed him with the put down, but we all know the world is non-linear. So even people introducing major techniques for the first time can receive these negative comments and reviews. If you do suffer from imposter syndrome, I hope you don't, Amy Cuddy's book called Presence is a good antidote to imposter syndrome, describes her early days as a researcher in psychology and some of the put-downs and challenges that she had. She suffered from imposter syndrome and has gone on to do very well as a researcher. But there's a lovely story in it about a famous novelist called Neil Gaiman, who was at an assembly of the great and good, people who had achieved things. And he felt, why should I be here? All these people have done brilliant things. What am I doing here? Despite being a prize-winning author, he suffered from this imposter syndrome. And he saw a friendly old man also standing at the back of the hall and got talking to him. And this friendly old man, whose name also was Neil, said, I don't know what I'm doing here. All these people have achieved great things. Why have I been invited? What am I doing here? And that friendly old man was Neil Armstrong, the first man on the moon even he was suffering from imposter syndrome. So Amy Cuddy's book might help you there, full of good stories about how to overcome these self-doubts. Hopefully you don't have them. If you do, have a look at that book. Okay, other things that can affect our confidence as researchers. Often we get disappointing results in a study. We expect to get some results. We have a theory which we hope will be played out by the results. But often the data don't conform to what you expect. Often it's a complete surprise. A few years ago, with colleagues, we did an experiment where we wanted to see if people could accurately adjust baseline statistical forecasts of demand for the effects of sales promotions. So you'd expect people to adjust the forecasts upwards if a product was being promoted. The question was, could they adjust them upwards by the appropriate amount? Could they judge from the information about the promotion how successful it would be? When we got the data, many people had adjusted the forecast downwards, and we couldn't understand why. Completely disappointing. Alternatively, if you do run experiments in my area, judgmental forecasting, there's a danger that participants trying to be helpful will try to second guess what you want them to do. And that, of course, may not be what you want them to do. And as a result, their behavior is distorted and you get weird results that you weren't expecting. It can all be very disappointing. It can affect your confidence again. It's all part of research. And after all, getting strange, unexpected results may even lead you to a novel discovery. Investigating anomalies and strange things can actually lead to big findings. So it's all part of research. What about rejections? We all get rejections. Again, standing back, it's easy to say this, we can use these and criticisms to improve our performance. If the criticisms are constructive, they can be very helpful. We can improve papers. We can even think about novel areas of research. We all get rejections. A referee once made strong criticism of a paper I'd written, basically saying that the error measures we'd use were inappropriate. And they recommended the use of the SMAPE, the symmetric multi-attribute percentage error. Well, I looked into this measure, and this led to a paper on its limitations. So it gave me a new thing to write about. And as a result, a paper looking at the limitations of the SMAPE emerged. So sometimes these criticisms can lead to new discoveries, new papers, new lines of research. Even Nobel Prize winners have had rejections. This is not a forecasting example, but Dr. Tom, I can't see his name on my screen because it's covered up. Give me a second. Anyway, I'll just go back a stage. Who won the Nobel Prize in medicine, he said, of course I've had rejections. It's very rare, almost unknown, to get a letter from the editor saying, we love your paper, we'll publish it without any changes. So even Nobel Prize winners will tell you about their rejections. That's not in forecasting or economics, of course. That was a Nobel Prize winner in medicine. Being challenged is a desirable part of research. It's the way we move on. But of course, editors and referees can get things wrong or make unfair criticisms. A paper I wrote with Robert Fields and several other people was rejected by Management Science in less than 4 hours. We thought it was a good paper. They can't have read it in that time. I believe they can't have read that paper. And later on, it was published in the International Journal of Forecasting and now has nearly 400 citations on Google Scholar. So because one journal rejects a paper doesn't mean that others will. I remember once submitting a paper to the Decision Sciences Journal. Again, it was based on a laboratory experiment. And referring to this experiment, the editor said, you could have told the participants what forecast to make. The implication was that we'd walked around the room and said to this person, you make a forecast of 400, you make a forecast of 280, so that we get the results we wanted. A totally, in many ways, scandalous and unfair criticism. But you do get these. Again, it's part of the nature of research and publishing. If you think they're wrong, there's always another journal that you can try. But if you are a referee, my advice is to provide constructive criticism. There's no point in being nasty and unpleasant about it. It doesn't help anybody. Okay, I now want to look at some problems or mistakes that I've made or which I've seen in papers that I've refereed, which basically it's easy to make. The first is confounding in experiments or confounding in whichever research you're doing. George Wright, who's the editor of the journal Behavioral Decision Making, a psychology journal, told me that that's the most common reason for papers to be rejected, that two treatments have been confounded. Of course, by confounded, I mean you've changed more than one thing at a time, and yet you're attributing the effect to just one of those changes. Typically, an example might be a problem of testing out the type of advice to provide forecasters in order that they will avoid overconfidence. Overconfidence is when they come out with judgmental prediction intervals that are too narrow. And we might be trying to help them to avoid this. So that we could have two treatments. One would be to give them fixed advice at the start of the process, at the start saying, please avoid being overconfident in some way. And the second treatment, competing with it, might be to give them dynamic advice during their forecasting where we adapt to the forecaster performance. So we say, well, you've just done this, you should have done that. And we provide this every few periods. And I might draw the conclusion that the dynamic advice is more effective than the fixed advice. But of course, if you think about it, the dynamic advice involves confounding the type of advice with the number of times the advice is provided. It may simply be the reinforcement of the advice, the repetition of the advice that causes the effect, not the adaptation of the advice to the person's particular errors and mistakes. So it's very easy to confound things in experiments, and sharp referees will spot this and advise you accordingly, I think. So try and avoid confounding. Okay. Okay. Another particular thing in forecasting work is people using insufficient out-of-sample observations. Now, complex statistical methods can require lots of data in the estimation process. And it's tempting to try and use almost all the information for fitting in order to get the best possible estimate you can of your parameters, and leave very little for out-of-sample testing, very little unseen data for testing the true forecasting ability of the method. I came across one study a few years ago which used just 2 out-of-sample observations, and it concluded that a polynomial curve and moving average combination projection model, a PCMACP model. Notice there are 7 words in the title, that it could reliably and accurately be used for forecasting natural gas consumption. But they'd only really tested it on 2 unseen observations. But notice the great long name. This led me to put forward the tongue-in-cheek rule, that if the name of a method contains more words than the number of observations that we use to test it, in this case, I think there are 7 words, there may be more, and only 2 out-of-sample observations. If you have that situation, it's wise to put any plans to adopt the method on hold. People often go for very complex methods with great long names, but only test them on 1 or 2 out-of-sample observations if you're lucky. So that's, I think, one mistake to avoid, not testing your methods on sufficient data. The third thing is an absence of appropriate benchmarks. Can the complex method that you're proposing actually beat naive forecasts? A naive forecast, of course, is simply one where you use the most recent value to forecast the next periods. Or can your complex method beat an existing widely used method? If it can't, we may as well stick with the existing method. For example, Google flu trends, the Google flu trends model, I think it's no longer being used, but it was being used a few years ago to try and forecast outbreaks of the flu. Apparently it's a complex model with 45 variables. But according to a recent paper that is forthcoming that I've seen, it was actually less accurate than naive forecasts. You got better forecasts simply by using the most recent observation of flu cases. You didn't need a model with 45 variables. So we should always have, I think, decent, simple or existing benchmarks. Of course, simple methods tend to avoid overfitting and therefore often perform relatively well against a complex method. A lot of studies simply compare one complex method against another. I think I'd always try and include something that was simpler or an existing method. Of course, accuracy measures like the geometric mean of relative absolute errors, the gum ray, can be useful here because they have a built-in comparison of two methods. They build in the comparison of the method you're testing with a benchmark. So measures like that, I think, should be widely used. What about other mistakes to avoid? Well, often we apply significance tests to our research. Is one method significantly more accurate than another? But of course, most of these significance tests require that the observations that you have are independent. Let's take the example I've got here. I've got two forecasting methods, and I've shown you the errors in those methods, the absolute errors in those methods from January to July. And I've been considering applying a sign test to see if one method is significantly better than the other. But of course, if those successive errors are not independent, I shouldn't be using a sign test or even a paired t-test because they assume you've got a set of independent observations. You may say, well, if these are errors, they may well be independent because a good forecasting method leaves white noise. But of course, if these are judgmental forecasts, the errors, the successive errors may well be correlated, and they're therefore not independent. And also, I've found even in good journals, there are papers that make this error. Suppose you've got 30 participants in an experiment and they each make 12 judgmental forecasts. Well, you haven't got 360 independent observations there because each participant is making 12 forecasts. Therefore, their forecasts are likely to be dependent on one another. It's tempting to say we've got 360 independent observations there. We haven't. So be cautious when papers quote tests involving hundreds or thousands of degrees of freedom. Ask, have they really got that number of independent observations? They probably haven't. They probably should be grouping and aggregating some of those observations to make them independent. Another mistake is a widely known one, you may be well aware of this, is confusing practical significance with statistical significance. Method A might have a lower mean absolute error than method B, so we reject the null hypothesis that there's no difference in accuracy of A and B with a p-value of less than 0.01, and conclude therefore that method A is the best method. But the MAEs may only be 205 and 207 units. There may be very little between them. So really hardly worth doing the test. We should therefore publish effect sizes, not just p-values. Show what the size of the effect is. I think that's becoming more common, but years ago, people used to just quote p-values. You didn't know whether the difference was big or small or negligible. And I think this is my final mistake to avoid. Dust bowl empiricism. Dust bowl empiricism is making empirical observations and collecting data rather than establishing a theoretical framework. So we collect lots of data and by chance we find patterns in that data or we find that one method is better than another, but we've no real understanding of why or no theoretical framework with which to judge those observations. For example, method A outperformed B on a set of data. We really need to know why as researchers. It's not enough to know that A did better than B. We really should search for why is this method. If we don't know or we've no theory, we can't really generalize the findings. We can't say, well, in general, these methods will perform well in this situation and these methods will perform better in another situation. We're saying that some people appear to take a different view. Richard Burke, who's professor of criminology and statistics at the University of Pennsylvania, he makes forecasts of crime, and he says, if the computer finds things I'm unaware of, I don't care what they are, just so long as they forecast. I'm not trying to explain. So it doesn't matter if he doesn't understand why a variable is improving the forecast. As long as it improves the forecast, he's satisfied with that. But of course, he may have a slightly different objective from us. His objective is simply to produce accurate forecasts. As researchers, Our objective is to understand why. We're not just interested in the forecasts themselves. We want to know why they work. What is it that drives their performance and so on? So I think we have a slightly different agenda than Richard Burke. Okay, what attributes are there of a good paper? I probably don't need to tell you this, but it's worth spending a few seconds on it. Well, first of all, it should be clearly written. Always a temptation to write to impress, using unnecessarily obscure language, I think, when you start out. You read these dense papers and you think, well, I can't write something simple and accessible. It won't be impressive. I don't understand a word of it, so it must be good, is the philosophy. I don't understand this paper, it must be brilliant. Well, I don't think that works. Tversky and Kahneman, of course, who are world famous now, their work is highly accessible. And I think one reason why they're so well known and famous is that even if you're not a psychologist, you can go to their work and understand it. They don't write in highfalutin, unnecessarily obscure language. Their work is accessible even to non-specialists. If you can make your work accessible, then quite clearly it's advantageous. What are the other attributes of a good paper? Well, I think obviously having clear and interesting research questions or hypotheses, clearly being based on the existing literature and then going ahead and advancing that literature. Telling a story, I think. I once had a colleague who was struggling to get a paper revised, and I said to him, well, what's the story? What's the story you're telling here? Where does it start? What does it go through? Where does it end? And that enabled him to improve the paper, which was ultimately accepted. And of course, always acknowledge the limitations of research. When I'm refereeing papers, I very often, and even if it's a good paper, I often say, well, surely you should have some limitations to your research. It's good practice to acknowledge these. No research method is absolutely perfect. All research methods have their limitations, and it's always a good idea to acknowledge those. Nobody will think worse of you. They'll think better of you because you've been able to stand back and evaluate the quality of the research that you've done. What about choosing a journal in forecasting? Well, the first thing is that if you're new to forecasting, beware predatory journals and publishers. They often charge you for publications. I mean, why should you pay to have your paper published? They often have no editorial or academic standards at all. They don't even have peer review. And therefore, getting a paper in that journal will bring you no benefits at all for anybody who knows which journals are good and bad. It won't advance your career. Many will take payments and then won't even publish the work. But if they've got your money, you never see your work in print. And just show how mad the situation is, I've even been invited to contribute to dentistry journals. I know nothing about dentistry, but I've had people quoting my papers and saying, we think you'd be a great author of a paper for our dentistry journal. Total nonsense. You've probably all had emails like this. Dear Goodwin P, hope everything is fine for you. Well, that's very nice of them. Your article, Contrast Effects in Judgmental Forecasting when Assessing the Implications of Worst and Best Case Scenarios, published in the Journal of Behavioral Decision Making, has impressed us significantly. Well, that gives me a nice warm feeling. They're impressed with my work. Hooray. Here we strongly invite you to contribute other original articles to our journal. Well, total nonsense. They've not read my paper. They don't even know how to, what the format in which to put my name. This is a sign of a predatory journal. Avoid like the plague. What are the red flags then of a predatory journal? Well, they appear on Cable's or Cabell's list of predatory journals. Worth looking that up before you submit. And some journals are right on the margin of being predatory and otherwise. Some relatively well-known journals are on Cable's list. So do have a look at that list if you're doubtful about a journal. There's often no named editor. They claim international scope, but if you look at the editorial board, there's little geographical diversity. That's assuming the editorial board is genuine. I was informed by a colleague some time ago that my name was on an editorial board of a journal I'd never heard of. Somebody had got my name and stuck me on the editorial board. I'd never heard of the journal and never agreed to it. But the most obvious red flag of a predatory journal is the promise of rapid publishing. You know, we'll publish a paper within 2 weeks. Sounds wonderful. Academic standards cannot be maintained with that turnaround of publication, I don't think. So avoid predatory journals. If you want looking for a good journal, ratings such as those of the Association of Business Schools, that's a British list, the ABS list, they provide some guidance on quality, but they're not perfect. For example, in Britain, we have what's called the Research Assessment Exercise, which rates university departments on the quality of their research. And in their report, the Management Science Panel said that top quality work could also be found in journals occupying a lower position in the conventional rankings. So a lot of journals with nothing like a top rating often carry good work. In fact, Mingus and Xu in 2010 formulated what they call the journal effect theory. Journals become established in a way that means authors cite the journal's papers simply because they're seen as the top journals. Oh, this paper is in management science, I better cite it, over and above the quality of the papers themselves. So papers in top journals get cited not always because they're good papers, purely because they're in top journals, according to Mingus and Xu. Continuing with the theme of choosing a journal, there's some suspicion that there occasionally are cultural nuances to journals. For example, if you look at management science, I think roughly 83% of its department editors are US-based, whereas the European Journal of Operational Research, all 6 editors are European-based. And when the EJOR, the European Journal of OR, was formed, there was one of the rationales for it was the suspicion that there was a slight bias against European authors in management science at the time. Now, I have no evidence for that, but it's worth bearing in mind when choosing a journal that there may be slight cultural differences in the way papers are looked at, depending on where the editorial board is largely cited. Journals that say they don't take forecasting papers include Omega, surprisingly. Robert Files and I recently submitted a paper to Omega and were told that they didn't publish papers on forecasting. When we queried this, we said, well, you've had a recent special issue on the subject of judgmental forecasting. They said, well, that was just a special issue. They brought in special editors for it, but they hadn't got the editors for routine papers who could take a look at forecasting papers. So I'm surprised. I've had a few papers in Omega, but nevertheless, that's the message we got from the editor, that they don't take papers in forecasting. And I also once submitted a paper to operations research letters, and they told me that forecasting was beyond the scope of their journal. Things may change, of course, but do look carefully to see if a journal does take papers in your area, to save wasting time. Okay, getting cited. We all like to be cited. So what pointers are there to getting our papers cited and publicized through the network of researchers in our area? Well, Mingus and Xu in 2010, I've just referred to them, they did a study of management science journals. They didn't include forecasting journals, but we often publish in management science journals, of course. And there's their regression equation to show the effect of different attributes of a paper on its number of citations. All of the parameters with asterisks next to them are significant. So you can see the more pages your paper has a slight effect on citations. The more references it has a slight upwards effect on citations. They then compared the nature or the type of paper using a viewpoint paper as the base, where you give your views on a topic. So you can see theoretical papers were cited more than viewpoint papers, empirical papers were cited more, but review papers, literature review papers, were cited much more. If you want to get lots of citations, a literature review paper tends to get them because, of course, everybody goes to the review paper to see what the state of the art is. They also compared the different journals for their likelihood of gaining citations. And in this case, Omega was the base journal. They also included Decision Sciences in the Journal of the OR Society in the data set. So you can see, compared to Omega, management science got a lot more citations. EJOR, the European Journal of OR, got more citations, and operations research did. But Decision Sciences in the Journal of OR Society were not significantly greater than Omega in the number of citations they did. I don't know if that's helpful. It's interesting, I think, to look at. The study is 10 years old, so things may have moved on since then. There have also been some rather dubious studies about what gets you cited. This is not a forecasting example, but Research Trends conducted a study of papers published in the biological journal Cell between 2006 and 10. And they found that papers with titles between 31 and 40 characters were cited the most, and papers with question marks in their titles were cited less, but titles containing a comma or a colon were cited more. Take this with a pinch of salt, is my advice. This, I think, is Dust Bowl empiricism. Nobody's really got any theory as to why this should be the case. And of course, there's bound to be papers. Some papers are bound to be cited more than others, and they might just happen to have certain characteristics. It doesn't mean there's a causal relationship there. So I think studies like this can be treated with some caution, with a pinch of salt. Another study by Dcge and Yeshian, they studied 2 psychology journals. Many of us publish in psychology journals, of course, if we're studying judgmental forecasting. And they found that papers with highly amusing titles received fewer citations. So perhaps the moral is don't try and have a joke in the title. But again, treat that work with some skepticism. So how do you get cited? Well, I think the true answer is you need to be addressing interesting, simply stated research questions. So, for example, do people trust forecasts produced by humans more than those produced by computers? Simple question. Do people understand probabilistic weather forecasts? Do neural networks outperform expert stock market forecasters? All of these very simple questions. There's a publication in Britain called The Conversation, where you can publish articles about your research aimed at the general public. Often worth saying, would this make a good newspaper story or a story for The Conversation? Something that's newsworthy. Propose something novel or radical. That's likely to get you cited. Many years ago, I wrote with George Wright a paper on combining scenario planning with decision analysis. And it's been one of my most cited papers because it was a bit different, a bit radical, I think. Okay, what possible research areas are there? Well, there are many, many possible research areas. So I'm probably a little bit blinkered in this. So don't just stick to my list. But I think one thing that's neglected in research, but is very necessary, is replication. The International Journal of Forecasting states the IJF encourages replication studies. So they encourage people to try and see if they can get the same results or the same findings, either on the same data set, that's called reproducibility, or on different data sets, that's called replication. Now, some areas, notably psychology, are said to be facing a replication crisis. For example, a famous 215 study found only 40 of 100 studies in top psychology journals could be replicated. And here's some of the famous papers that couldn't be replicated, both published in the top journal Science, would you believe? One paper found that washing your hands stop you worrying about past decisions. That got into Science in 2010. It couldn't be replicated when they tried it. Another paper that got into Science, again, a psychology, not a forecasting paper, but the same principle holds. Looking at Rodin's statue of the thinker makes you less religious. Well, it seems very dubious to me. Not surprisingly, it could not be replicated. So be careful before you accept this story, which I read in New Scientist a couple of years ago. Walking backward improves short-term memory. Well, before you start walking backwards and falling over and so on, remember that hasn't been replicated. I'd like to see the results repeated a few times before I believe that story. If you're interested in how to reproduce or replicate studies in forecasting research, the IJF published a paper by John Boylan and others, including myself, in 2015. And there we discussed the process of replicating and reproducing studies in forecasting research. So that might be helpful. What potential areas, other potential areas are there? Well, I think we need a lot more work in probabilistic forecasting. Papers on point forecasts tend to predominate. In judgmental forecasting, most papers tell us how awful judgment is, all about the biases and inefficiencies. We probably need more on solutions to the problem. Artificial intelligence in forecasting, surely lots of potential for work there, but it must be tested against appropriate benchmarks. Simple benchmarks, ideally. And there's a need for qualitative rather than empirical research in forecasting. How do organizational factors impact on whether forecasting practice is good or bad? And what are the barriers to implementing good practice in organizations? This might lend itself to qualitative rather than quantitative research. And how do we enhance trust and understanding in forecasts? Many people don't understand what forecasts are about, what they try and achieve, and as I said earlier, what their strengths and limitations are. How do we educate people to improve trust and understanding in forecasts? So here are my conclusions. Be confident in your research, but still be open to constructive criticism. Confident, but open-minded. Be resilient. If you get rejections and people saying nasty things, be resilient. Don't give up. Carry on, fight on. We've all had these challenges. Good researchers are strengthened by challenges. Be persistent. Carry on with a research area that you're confident should yield results. But of course, there's always a point where perhaps you should give up. Don't flog a dead horse. Avoid the sunk cost fallacy. Don't say, well, I'm going to continue this research because I've invested years and years of work in it when it's no chance of success. So be persistent, but also know when to quit an area that is being unproductive. Be rigorous as well in your research. Be innovative, but don't ignore the need for replication. So invent new things, discover new facts, but still remember replication is a much needed aspect of forecasting research. Be in fact impactful. Ideally do research which will improve forecasting in organizations, that will improve the way that forecasts are viewed and used in the world. So forecasts that have impact are surely far more useful to us than forecasts that are purely theoretical and go nowhere. But above all, enjoy what you do. No point in doing research if you hate every minute of it. It's a great topic to study, a great topic to research. Whatever you do, make sure you enjoy it. Thank you very much. I'm happy to take questions.
Thank you, Paul. Thank you very much. We have 8 minutes. Do we have any questions? Yeah, I want to give applause as well. Okay, I will start actually. Paul, I really enjoyed your mistakes and what to avoid and some recommendations as well. But I have a question in more general view, I would say. From your experience, how many papers did you publish that you actually wrote? Like the proportion of these papers that you don't flog a dead horse and stuff like this, if you see what I mean.
How many papers, how many times have I written papers that
and gave up later on? Yeah, maybe.
Oh, that's right, yes.
Yeah.
Well, I think I've probably done 2 or 3 papers which have never been published, although one which has been around for 15 years, which I've written with Robert Files, has just been accepted for publication after years and years and years of revisions. I was quite willing to give up on that one. That's coming up in the International Journal of Forecasting. But you know, occasionally I think we all often face this. I've slightly been deluded and thought that a topic was interesting and worthy of publication, and you spend time on it. And one night, often in the middle of the night, it hits you that the idea wasn't a very good one, and so on. So I'd probably 2, 3, 4 papers, I think, over the course of my whole career, which I've come to realize were leading nowhere. And certainly were not of sufficient quality ever to be published. But of course, often you don't know that until you get into the research, of course. And research often involves thinking problems through, and it sometimes takes a while to reach the conclusion that the work is not leading anywhere productive.
We actually got a question from Ivan that actually I think is a good continuation of mine as well. What is your best paper and what is your most cited paper? Are they the same things?
Well, I'm not sure that they are. The most cited paper is, I think it's a 2000, I can't remember which year it's published. It's it's a review of 25 years of judgmental forecasting, which I published with Delarc-Oncle, Michael Lawrence, and Marcus O'Connor. That's the most cited paper, but it is a review paper. As I say, review papers do actually lend themselves to being cited readily, because that's the repository of research at a current point, and naturally researchers will go to that. That's the most cited one. The second question is quite difficult. Which is the paper that I think is the best? I'm quite proud of a few papers. In a paper I can see Dcge is there. We did with Dcge, which asked the question: do people accept algorithmic forecasts more readily than judgmental forecasts? And we found that people suffer from a form of algorithm aversion. They basically trust forecasts from algorithms less than they trust forecasts from human judges. I think that was quite a nice newsworthy paper. In fact, that paper even got into the press a few times in newspapers, that people trust humans more than they trust algorithms. Can I come back in a year's time and actually, having reflected on that, and try and give you a better answer? Sure. I can't even remember most of the papers I've published, I'm afraid.
Sure. Okay, we have another question from Jonathan Cream. Has there been a reconsideration of Dcge models in macroeconomic forecasting since the global financial crisis?
Right. Well, I'm not an expert in macroeconomic forecasting. Most of my forecasting is company-based demand forecasting. So I'm really not a specialist there. So I can't really answer it, but I think I would hope that there would be a reconsideration of macroeconomic forecasting, given the major assault on the economy as a result of the coronavirus. So I think that I would hope there has, but I don't know. I looked a little bit at judgment in macroeconomic forecasts, but I'm not a specialist in econometric forecasting or macroeconomic models of that type.
Nikos, I saw your hands up. Do you want to ask a question? Go ahead and just...
Yeah, I can ask. Paul, I noticed you mentioned that slide about the criminology professor who's doing crimes with forecasting.
Yes.
You were very polite to him, saying that you can trust the forecast, that it's a black box. But in the context of the discussion, I would ask you, from your experience of publishing papers, you can sum up some of the attendees here and still have more years in publishing papers. How would you respond to the two extremes of this critique? Either your forecast is lacking the theory, or your forecast is lacking the empiricals, arguing that, at least in my perspective, that forecasts are always somewhere in the middle.
Yes, well, I certainly wouldn't go to the extreme of the criminology professor. I mean, there's another quote, isn't there, from the editor of, I forgot which journal it is now, who said, we don't need explanations, terabytes are enough, because, I think there's a great danger in not understanding it. An example I've given in talks to MBA students is, supposing I've got a big data set, I'm running a supermarket, and I find there's a very high correlation between the sales of printer cartridges last week and the sales of cat food next week. Do I use that in my forecast? I've no explanation as to why there should be a correlation between printer cartridges and cat food sales, but there does appear to be one. And my answer, I'm afraid, is I wouldn't use that until I understand why, because I think somewhere along the line you're gonna come a cropper. So I think you should have at least some notion, some sanity check on any relationship that you use in forecasting. Perhaps not a complete theory, but it should at least appear to be reasonable, or you should have some evidence as to why it's occurring, I think. I certainly would not make forecasts using variables whose relationship with the dependent variable I didn't understand.
Okay, sorry. I see Devon, you asked a question. Do you want to elaborate this and ask it if you have your mic around, or I can read it out?
Can you hear me?
Yes, I can hear you, Devon, yes.
Yeah, okay. I mean, my daughter's in the background somewhere, so forgive if you get some extra sound effects coming through. But yeah, I guess maybe I will shape it in a way where it's also relevant for very early career researchers. My question is around, keeping yourself motivated. Obviously, as Nikos has mentioned, you've been going for a very long time. So from sort of early to middle and beyond, how do you keep yourself motivated and sort of avoiding the feeling of, okay, yet another paper?
Well, I've never had a problem with that. I mean, I'm, obviously getting on in years now. I still get excited when I've had a paper accepted. I mean, I probably had about, over 70 papers in peer-reviewed journals. But it's a red letter day, as we call it. It's a good day when I get that letter from the or email from the editor saying your paper has been accepted. There's a certain thrill that you've found something out, you've discovered something new, and it's going to be publicized in a journal. So I did start, perhaps one thing worth saying, Devin, is I did start research relatively late in life compared to most of you. I spent a good many years at a teaching university and college where there was never any time to do research. So I didn't do my PhD straight after my master's degree or my first degree. I was, getting on into my 40s when I did my PhD. So I suppose in many ways, I haven't reached that advanced age of my research, really. I'm still probably in the middle section now. I'm still middle-aged in research terms, although I'm ancient in chronological age. So for me, the motivation is still there. The motivation is still there. If you feel that you're losing it, I mean, it's such an exciting area, forecasting. It's tough to know how you would lose it. And there's such a great body of people who you meet at conferences, COVID permitting. There's an awful lot of encouragement, I think, surrounding forecasting with all your fellow researchers and so on. So my advice is my hope is that you won't lose your motivation and that you'll still enjoy publishing papers for many years to come.
Thank you. And
thanks.
We're actually a bit behind the schedule. So the last question that Dan Juham, sorry if I read your name wrongly. Professor Paul, do you consider scenario-based forecasting as probabilistic forecasts? Is there any established method of assigning numerical probabilities to scenarios a forecaster comes up with?
Right, well, scenarios are defined in all sorts of ways. It's largely a practitioner-driven methodology, and different practitioners have different definitions of what a scenario is. The sort of scenarios I've been involved in don't have probabilities. In fact, we recommend them purely because people are so poor at estimating judgmental probabilities. The sort of scenarios I have simply set bounds to the range of possibilities. The trouble with assigning a probability scenario is, in theory, the probability of a particular combination of events that form a scenario actually showing up is infinitesimally small. It's very, very unlikely that that particular combination of events will occur. So the probability is almost by definition almost zero. But there are methods where people assign probabilities to scenarios. But I haven't been involved with those myself. I prefer to see scenario-based work as being an alternative to probabilistic forecasting, where you simply set the bounds to what can happen, and you devise strategies that will help you to survive and prosper whatever occurs between those two bounds. So it's like a robustness test for your strategies. So I've no experience of assigning probability scenarios. I'm not sure even if it's philosophically possible.
Okay. Okay, thank you very much, Paul. Thank you very much for all your comments, for your presentation. We will put this presentation on YouTube, so many more people will see that. Thank you again. Thank you for coming, all of you guys, 25 participants right now. See you next time. And again, follow our page in order to see our next events. Thank you very much. Thank you, Paul, again.
Thank you.
Bye-bye.